Okay, this is our first practice video of the second semester, linear algebra. There's an interesting way in which the author of the textbook refers to the chapters. He uses acronyms for the title of each section because the first section is called What is Linear Algebra? That's what we'll use as the acronym for the section. In addition, all the homework problems will have that as their preface. So this is WILA.C10. Okay, the first question asks to kind of show that this example, which they used of the trail mix, fits into the pattern of a linear system. And so what we're going to do is write equations that identify the cost of each one of the kind of mixes using the individual costs in bulk of the mixture materials together with what the cost of each mix is. So first, the bulk mix. If I had to write an equation for the bulk mix, it would be that 7 units costing $2.55 each plus 6 units costing $4.65 each plus 2 units costing $4.80 each should be equal to a 15 units, because that's the total of 7, 6, and 2, costing $3.69 each. Now that actually is a true statement. And of course it looks linear because we have these coefficients for the costs. And of course the costs themselves are going to represent our variables x1, x2, x3, and then we'll end up with some sort of an answer. Let's do the same for the standard mix. So that would be 6 units of $2.55 plus 4 units of $4.65 plus 5 units of $4.80, and that is 15 units again, which costs $3.86. And that is again a true statement. And you can start to see the pattern here that the costs represent our variables and the coefficients represent the coefficients of the linear system. So finally, the fancy mix, 2 units of $2.55 plus 5 units of $4.65 plus 8 units of $4.80 would be 15 units of $4.45. And there it is. If we divided 15 across the board, then these would be coefficients that were fractional. We'd end up with columns that represented our variable, and of course we'd end up with our answer vector right over here. So looking very much like a linear system.